Now that you've seen me do multiple proofs involving even and odd numbers and prime numbers, do you feel confident that you can do a proof yourself? Why don't you pause the video and see if you can prove or disprove the following statement. If A is any odd integer and B is any even integer, then it has to follow that the quantity 2a plus 3b is even. See if you can do that yourself. By the way, this is a true statement, so it must be proven. So I hope you took some time to try this problem out. And I'm going to begin by proving it by writing the word proof at the very beginning and then choosing the A and B, just like the theorem or the statement in the problem wanted me to. I'm going to pick A to be an odd integer and B to be an even integer. And I would like to show that 2a plus 3b, the quantity, will become even. Again, this is a comment, that's why it's written with the brackets around it. Eventually, these comments can be erased and they don't have to be written down. Now, by the definition of the terms odd and even, we can say the following. There exists m and n that are integers, such that a is 2m plus 1 and b is 2n, because a is odd and b is even. Now let's consider the quantity 2a plus 3b. This just means that I'm telling the reader to pay attention to the quantity 2a plus 3b, which is the one that I'm trying to prove something about. So after I've exhausted all my definitions, after I've used all the terms, the definitions, and the variables, I'm going to pay attention to the quantity that I'm trying to prove something about. In this case, the quantity is 2a plus 3b. By direct substitution, I can replace the a and the b with the appropriate numbers, and then just FOIL or distribute everything out to end up with 4m plus 2n, plus 2 plus 6n. And then I can factor the 2 out, and when I factor it, I get 2m plus 1 plus 3n inside the parentheses, but m and n are themselves integers. 3, 1, and 2 are integers, so all I'm doing here is adding and multiplying a lot of integers with one another. And by closure, it stays an integer. When you multiply and add and subtract integers, you stay integer. That's important because now I have 2 times an integer equaling to the quantity 2a plus 3b, which implies that 2a plus 3b is even. And that's what I wanted to show. That was my little comment from earlier. So that proves the statement of the theorem, or the statement in the question.